It's a huge, huge advantage to know the truth because once you accept that climate change is real, that global warming is real, that anthropogenic CO2 rise is real, and open your mind to the unexpected, you get to ask and answer the big question. To solve the climate change mystery, we need to start by first answering two key questions. Did an increase in solar output occur over a long time period when global warming was occurring? And was that change large enough to cause the climate change? To answer the first question, we turn to history. Solar output has risen since the end of the Little Ice Age, but very little. Using averages spanning more than 11 years to account for solar cycles, we see that there was only a half of a watt increase in the past 127 years, but it did occur during global warming. Now let's answer the second question. Only about 14% of that change reaches into the ocean. Ouch, this is not looking good. That seems really small, like having one LED on your Christmas tree. But then again, the oceans do cover 360 trillion square meters, and we're talking about a time period of 127 years, or 4 billion seconds. Maybe we should avoid jumping to conclusions and just do the math. A change in temperature is a function of heat, mass, and the specific heat capacity of a material. Toss in the numbers for heating up the entire euphotic zone, which is the fairly isothermal top 80 meters of the ocean, and you get a staggering 2 degrees C increase, far more than what the seas actually warmed. But the IPCC has estimated that 97% of that gain is lost to heating the atmosphere, which then loses that heat to space. And yes, that leaves a gain at the sea surface and atmosphere that matches NOAA's best estimates of temperature gains since 1893. An ocean sea surface change of 0.9 degrees C and an atmospheric change of 1.5 degrees C. Was the change in solar output during the same period of global warming? Yes. Was the change large enough? Yes. Enough to explain ocean temperature rise and global warming. But how does that theory align with facts? Do climate records support the theory? Let's look at one-year changes in sea surface temperature, atmospheric temperature, and oxygen of life to witness in actual climate records the exciting dance production put on by Mother Nature showing actual cause-effect and feedback. The white line shows yearly changes in climate since 1985. Note the large ups and downs. Something is causing those large ups and downs. Now watch how sea surface temperatures, the green line, not only tangos with the rise and falls of climate change, but leads that dance by 2 months, the time it takes the oceans to warm or cool the lower troposphere. Next, we see the blue line, oxygen of life, in the dance of the protagonist, the negative feedback. When Earth gets too hot, the seas release dissolved oxygen of life back to the atmosphere so that photosynthetic life can increase and cool the Earth. Unimpeded, solar radiation bombards the surface of Earth, making it too hot. But with oxygen of life growing more photosynthetic life, solar heat is converted into sugars, resulting in less solar heating of the atmosphere, so Earth can cool. Yes, oxygen of life does have an impact on climate. It heats only when Earth is covered in ice, which makes oxygen of life totally awesome. It heats when Earth is too cold. It cools when Earth is too hot. But for the negative feedback to be more effective, we need to restore oxygen of life back to the atmosphere to the much higher levels of the past, so that oxygen of life can stabilize climate change and ocean rise, green the world, increase habitat for endangered species, feed all life in the oceans and on land, and help the poor afford medical care and education. Let's summarize the cause of climate change. The sun irradiates Earth. Ocean currents and wellings store that heat. later releasing that heat to the air in complex ways, some taking years, some taking decades. The air loses that heat to space, and oxygen of life, it's a negative feedback, not a primary cause, heating when Earth gets too cold and cooling when Earth gets too hot. I hope you find this information interesting and useful.